Welcome to this video. In this video what we're going to discuss is the drugs amphetamine and methamphetamine. Topics we're going to cover then are firstly what actually are these two drugs, so we will look at the chemical structure of both amphetamine and methamphetamine. Then what we'll discuss is what are they actually used for, so we'll start off with their clinical uses to treat ADHD and narcolepsy, and then we'll discuss their use as a street drug. What we'll then see is different ways that they can be taken, so different routes of administration. We'll then discuss the actual effects that they have, and we'll specifically focus in on their effects on the brain. And then finally what we'll have a look at is what is understood about the mechanisms by which they actually achieve these effects on the brain. Okay, so our first topic then is what actually are these two drugs? Okay, well both of them are names given to a certain molecule. So amphetamine is the name given to a certain chemical structure. Methamphetamine is also the name given to a certain chemical structure. Okay, so both of them relate to an actual chemical structure, a drug molecule. Okay, my first task then is to explain the chemical structure of both of these drugs to you. Okay, so we'll start off with amphetamine then. Okay, and I'm going to draw their chemical structures in skeletal form. Now remember, when you draw a chemical structure in skeletal form, it looks very simple, and the reason is that you don't show carbon atoms. You show them instead by the corners of the molecule. Okay, in addition, you don't show hydrogen atoms coming off carbon atoms at all. Whenever you have a missing bond coming off a carbon atom, the implicit understanding is that that missing bond is to a hydrogen atom. Okay, so there's a little bit of a heads up on skeletal formulae. So now let's draw the skeletal formulae for amphetamine. Okay, so amphetamine then, one of the major things that it actually has in its structure is a benzene ring. So this is the thing I'll start by drawing here. Okay, so a benzene ring is a 6-membered carbon ring. So we've got 1, 2, 3, 4, 5, 6 carbons here. Okay, we've got alternating double and single bonds between those carbon atoms. And in pure benzene, what you then have is off each of these 6 carbons, you'd have a hydrogen atom, which we wouldn't show because we're drawing a skeletal formula, and you don't show hydrogen atoms coming off carbon atoms in skeletal formulae. Okay. However, we don't want pure benzene, so we better add something onto this. So onto one of the carbons, and I'll choose this one here, you take the hydrogen off it, and instead we're going to stick another carbon, which is going to be a methylene group. So it's going to be a carbon with 2 hydrogens coming off it. So here's the carbon, it will have 2 hydrogens coming off it, which we won't show, and then it will also have another carbon atom down here, which will then have an amino group coming off it. So here's an amine group coming off it. Now, in addition to the amine group, this carbon will also have another carbon coming off it in the form of a methyl group. And I'm not going to draw this methyl group in a normal way. You might expect me now just to draw a straight line down, but I'm actually going to draw a squiggly line, like so, to denote our methyl group. And I might just break with the skeletal formula for a moment and actually just stick the methyl group there. Okay, so that then is my picture of amphetamine complete. Okay, so I'll just box it in turquoise here because it's the star of the show. So here is the structure then of amphetamine. Okay, so the first task then is understanding why have I drawn this squiggly line here. What does this squiggly line actually represent here? Okay, well the squiggly line is there because this carbon here in the structure of amphetamine is actually a very special carbon. It has got 4 different groups coming off it, and therefore it is actually a chiral center, or because it's a carbon atom, we could indeed call it a chiral carbon. Okay, so firstly let me just convince you that it does have 4 different groups coming off it. So it has the amino group, this is one of its groups here in yellow. It has this methyl group, this is a second group here. It has this methylene group with the massive great benzene ring as one of its group here. And then where's the 4th group? Well, the 4th group hasn't actually been shown because it's just a hydrogen atom coming off that middle carbon atom. Okay, but that would be the 4th group. You'd have a hydrogen coming off here as well. So we do indeed actually have 4 different groups coming off this carbon atom. Okay, and whenever you have 4 different groups coming off a carbon atom, that carbon atom will be called a chiral center, and the reason it's special is that it will give rise to 2 different optical isomers of the molecule that it's in. Okay, so amphetamine then, the structure of amphetamine has actually 2 separate types. Okay, there are 2 different optical isomers of amphetamine, and I want to now explain this in more detail with another picture. Okay, so I'm going to draw out one of the optical isomers of amphetamine and explain what is even meant by 2 different optical isomers. Okay, so here then is the benzene ring of the amphetamine structure. Here's the methylene group, here is that chiral center here, and then we'll have the amino group here. So, to understand then why this carbon with 4 different groups coming off it is actually going to give rise to 2 different forms of the molecule, let's imagine that this carbon here, the chiral carbon, and I'll just colour it in green here. So let's imagine that that chiral carbon is actually sitting in the plane of the piece of paper. Okay, so it's actually sitting in the same plane as this piece of paper here. Okay, let's also imagine that the amino group here and the carbon of this methylene group are also sitting in the plane of the piece of paper. So this is in the plane of the piece of paper, and this is also in the plane of the piece of paper. Okay, now imagine in 3D then, where would the 2 remaining groups be going? Okay, so if all of these have been put in the plane of the piece of paper, where do the 2 final groups go? Okay, so the 2 final groups, one is a methyl group and the other is a hydrogen atom. Okay, so one of them is going to have to come out of the page towards us at the same sort of angle as my pen is at with respect to the piece of paper here. The other is going to have to go into the plane of the piece of paper away from us. Okay, and this is why there are 2 different forms of this molecule, because how do we decide whether it's going to be the methyl group that comes out of the piece of paper towards us and the hydrogen that goes into the piece of paper away from us, or whether it's going to be the other way around, the methyl group going into the page away from us and the hydrogen coming out of the page towards us? Okay, the 2 different possibilities are going to give rise to 2 different forms of this molecule, and those 2 different forms of the molecule are called the different optical isomers of the amphetamine molecule. Okay, so let me draw one of these optical isomers. So I'm going to draw the form where the methyl group is going to come out of the page towards us, and the way I will draw a bond coming out of the page towards us is like so, where the bond, the line for the bond gets thicker towards the end. So here is the methyl group coming out of the page towards us, and then the hydrogen will be going into the page away from us, and the way I will draw a bond going into the page away from us is as a dashed line like so. Okay, so here is a specific optical isomer then of the amphetamine molecule. Okay, and this specific optical isomer of the amphetamine molecule has a name. Okay, and you'll probably recognize this name. It is called D-amphetamine or dextroamphetamine. So I'll write out its full name here, dextro or D-amphetamine. Okay, so when people talk about dextroamphetamine, they are just talking about a specific optical isomer of the amphetamine molecule. Okay, so there is also another optical isomer of the amphetamine molecule. You can have it the other way round. You can have the hydrogen coming out of the plane of the piece of paper towards us, and the methyl group going into the piece of paper away from us. Okay, that other optical isomer is called L-amphetamine, or levoamphetamine is the full name for that other optical isomer. And these 2 different forms of amphetamine, dextro and levoamphetamine, they are truly different. You cannot turn one into the other without breaking bonds and reforming bonds, i.e. you cannot turn one into the other without a chemical reaction. So it is not trivial at all that these 2 molecules are different from one another. They are different from one another. And in fact, dextroamphetamine is the majorly active one. It's the psychoactive one. Okay, it's the one that produces a psychomotor stimulant effect. Whereas levoamphetamine It does produce a psychostimulant effect, but it is much, much less powerful at doing it than dextroamphetamine. So dextroamphetamine is the really active form of amphetamine. Now, if someone says that they are taking amphetamine, what they mean is they are taking a mixture of both dextroamphetamine and levoamphetamine. So that's the definition of what is actually meant by amphetamine. A mixture containing dextroamphetamine molecules and levoamphetamine molecules. Okay, which is why when someone asks you to draw the amphetamine structure, you would draw this diagram here with the waggly line, which means it can go in either direction. Okay, because this truly is a mixture of both of the optical isomers. If someone says that they are taking dextroamphetamine or D-amphetamine, then that means that they are specifically taking just this form, okay? They've got 100% that optical isomer, okay? No levoamphetamine in there, okay? They've got the more active one and not the less active one. Okay, right. So, then we have now taken on the two different optical isomers of amphetamine. Okay, and that's probably one of the most complicated concepts in this entire video. So if you've understood that, you'll handle everything else that we're going to discuss. Okay, right. So now that we've done amphetamine, let's now have a look at methamphetamine. Now, methamphetamine is only a very small modification to the structure of amphetamine, but it has the same difficult concept with there being two optical isomers of the molecule. So let me now draw methamphetamine's structure underneath the structure of amphetamine. So as I say, it's very similar. So we'll start off again with a benzene ring here, and then off the benzene ring we'll have a methylene group, and then off the methylene group a carbon, which will be our chiral center here, and then we'll have an amino group here. And again, this carbon will be a chiral center. It's going to have 4 different groups coming off it. Okay, and when someone talks about methamphetamine, it's going to contain a mixture of the 2 different optical isomers. Okay, now the big difference then between methamphetamine and amphetamine is that off the amino group here, we're now going to have an additional methyl group here. So there's another methyl group coming off this nitrogen atom. So methamphetamine then literally is just the amphetamine molecule with an additional methyl group stuck off the amino group of the amphetamine molecule. Okay, so here then is the structure of methamphetamine. Okay, right. So as I say, there are 2 optical isomers of methamphetamine, just like there are 2 optical isomers of amphetamine. Either this methyl group here can go, can come out of the page towards us, and the hydrogen can go into the page away from us. That optical isomer, just like this picture here, but with the methyl group coming off the amino group now, that is called dextromethamphetamine, or D-methamphetamine. Okay, so the naming is exactly the same as for amphetamine. The other optical isomer, where the methyl group goes into the page away from us and the hydrogen comes out of the page towards us, that will be L-methamphetamine or levomethamphetamine. Okay, so the nomenclature at least is consistent for amphetamine and methamphetamine. So once again, when someone says that they're taking methamphetamine, it means that they're taking a mixture of the 2 optical isomers dextromethamphetamine and levomethamphetamine. And also, just like for amphetamines, it's the dextromethamphetamine that is the more psychoactive of the 2. So dextromethamphetamine is extremely potent at causing psychomotor stimulation, whereas levomethamphetamine is far less potent. It's much less strong. It does have, again, a little bit of psychoactive properties, but it's far less strong than the dextromethamphetamine. Okay, so just like dextro and levoamphetamine. Okay, so now that we've discussed what actually are these molecules then, what I next want to discuss is what are they actually used for. So we'll start off with their legal uses, we'll start off with their clinical uses, and then we'll discuss their use as a street drug. Okay, so clinically, amphetamine and methamphetamine can be used to treat ADHD, Attention Deficit Hyperactivity Disorder. Okay, now ADHD is believed to be quite common, so it's estimated that approximately 10% of the population actually suffer with ADHD. And in ADHD, individuals have difficulty in concentrating. They have difficulty in consciously focusing their mind on a task. Okay, and this usually is detrimental in school. Okay, so children with ADHD have difficulty concentrating on the topic of the lesson, and they generally are quite disruptive. They don't learn that well in school. They disrupt other children's learning, so it is a problem for schools. Now, amphetamine and methamphetamine are given to people with ADHD, less so now since the popularity of methylphenidate has gone up. And they're given in much lower doses than they would be used as a street drug, and they do help to boost concentration. Okay, there's no doubt about that. They do improve concentration, and they improve these children's behaviour in school and their ability to learn in school. Okay, so amphetamine and methamphetamine can be used to treat ADHD. As I say, with the rise of methylphenidate, it's becoming less and less common to actually use these drugs for ADHD, but they are still used. Okay, the other big thing that amphetamine and methamphetamine can be used to treat clinically is narcolepsy. Okay, and narcolepsy, which is believed to be a form of epilepsy, is where people suddenly go to sleep. Okay, they are hit by uncontrollable sleep. Okay, so they will just be doing something, and then suddenly they'll just fall asleep. So it represents a problem with the mechanisms in the brain that control the onset of sleep. And what then happens is you get spontaneous activation of the mechanisms which lead to the onset of sleep, and then individuals just go to sleep all of a sudden when they don't want to go to sleep, and obviously this is a very debilitating condition. Now, amphetamine and methamphetamine, they do help in narcolepsy. They don't cure it, they don't stop it completely, but they have potent psychostimulant effects, and therefore they make you feel more alert and not at all like going to sleep, and therefore they do have some efficacy at preventing people suddenly going to sleep who are suffering with narcolepsy. So they are to an extent effective at treating narcolepsy. Now, the main thing then that we are going to be discussing in this video is the use of amphetamine and methamphetamine as street drugs. Okay, so illegally. Now, when people take them as street drugs, they take them in much higher doses than they would be prescribed for ADHD and narcolepsy, and therefore they get a huge euphoric high from taking these drugs, which people who are taking the medically prescribed doses will not get. Okay? Right, so before we actually go on to discuss what are the actual effects on the brain of taking amphetamine and methamphetamine, let me firstly discuss the different routes of administration for amphetamine and methamphetamine. So what are the different forms that they come in, and how are they taken? Okay, so we'll start off with amphetamine. Okay, so amphetamine has two main forms that people generally take it in. The first is that it can be taken in tablet form, so you can get amphetamine tablets or amphetamine capsules, and then obviously the way that you take those is usually orally. You swallow them, and then they are absorbed from the gastrointestinal tract. And amphetamine and methamphetamine both have very good oral bioavailability. Okay, so they're very effectively absorbed from the gastrointestinal tract into the bloodstream. The other form that amphetamine can be purchased in is the powder form, and the way the powder form can then be administered is either you can dissolve it and then inject it into the bloodstream, so the amphetamine therefore directly gets into the bloodstream, so the bioavailability will therefore be 100%. Alternatively, it can be snorted, okay, and then it will coat the nasal epithelium, and then it will be absorbed across the nasal epithelium into the blood vessels, and then again you've got the drug into your bloodstream and it can go to your brain. Right, methamphetamine, it comes in these two forms as well, so you can get methamphetamine tablets or capsules which you can take orally and then will be absorbed from the gastrointestinal tract. It also can be bought in a powder which can then be snorted or again dissolved and then injected intravenously. But the additional thing with methamphetamine is that you can also get solid crystals of methamphetamine, which are called crystal meth. Okay, so when people talk about crystal meth, they mean a solid crystal of methamphetamine. And these are sort of transparent crystals. They're very, very beautiful crystals, actually. I suggest you have a look at a picture on Google. And the way that people actually then get the methamphetamine from the crystal into their blood is they smoke the crystal. They set the crystal on fire, and then what happens is the methamphetamine goes from being in this solid form to being in a gaseous form, and then you inhale the vapors, and then just like oxygen would, the methamphetamine goes into your lungs and then crosses into the bloodstream, and then again you've delivered the methamphetamine into your bloodstream. Okay, so it's very similar to crack cocaine, which is a solid lump of cocaine which is then smoked and the vapors are inhaled, and that's how cocaine is delivered into the bloodstream. Okay, right, so that's what is meant by crystal meth, a solid crystal of methamphetamine, which is then smoked to deliver methamphetamine into the bloodstream. Okay, right, so I think we'll have a break there, and in the next video what we'll discuss is once you've actually got the amphetamine or the methamphetamine into your bloodstream, and it goes up to the brain, what is the actual effect on the brain?